Camera. Come in, please. Cela susa leya box. Thatha ruler, susan leyo box. It looks terrible. Okay, let's carry on with question. We are going to do question 3. So question 3 is about what? So we know that a course is a straight line that joins two positions. You've got the two positions there. So fix those two positions. So you've got, this is in false bay, né? Yes. Erasers. They are in the trunk there. This is false bay. False bay. Make sure that you do not become the light and the light becomes the shape. Keep the aspect the same as you seeing it on the campus rows. You are always at the center and things are all around you. And remember, your ship is always at the center. So right now you do not know what course your ship is steering. But I suspect it's going to be steering a southeasterly course because Roman Rock is up there and Cap Handclap Light is down there. Your ship is always at the center of the compass rose. So you line up the first bearing 210, 210. Should be something around about there. So you line it up with the center. Then you roll your ruler, or you move your ruler to Roman Rock. And I'll have a range of 2.8. So you should have something like that. A range arc and a line of position. Remember, the line of position always points away from the object that you are using. And it has an arrow away. Did they give you time there for that? So it was at 0800 and it's a fix. To show that it's a fix, you put the fix symbol. The next fix, I fix Cap Handclap 047. So the light is going to be to the north, to the northeast of me. And I'll have a range. Now when you join the two, I don't know how far you are, you should be, if you join the two, you should have that straight line constitutes the course that you have to steer to from those positions. Remember, try to make your work as seamless as possible. So don't move your ruler, move it straight to the compass and read the course so that you save time. The first quadrant thing is it's an estimate, so you'll put it there. As long as there's your heading, so somewhere there. Your line. Do you have an erase? Where's your first one? It's too small, that thing. At least when you're fixing, there should be about 1 centimeter of line on either side of the actual position where you are. Not you. Sulale chatting. You're going to be wrong. Work underneath you. From here. So why are you keeping your ruler this side? Your ruler should be this side so that you move a shorter distance. What course you getting? Huh? Question 3. Determine, we are still at 3.1. Determine the true course to steer. One arrow, not 2 arrows. And I don't want the line from the object. You must erase. And it's 1 arrow pointing away. No, away. No, the radar range gets 2 arrows to show that it's actually a continuous circle. And again, don't underline your course. You tell there must be a pencil's or a finger space between where the course is and where you write. You are not underlining the course. Yeah, 3.2. 3.2. Did they give you the speed of the ship? You'll see that you are not where you're supposed to be. You are not on your course. You are off course. And that's why we fix, so that you can determine whether you're staying on your course or are you to the right or left. So what are you discovering at 0900? Let me just check the same question from another year. Since we're dealing with one line, we get tempted to take the reciprocal. We need to be mindful of which way are we headed. Okay, guys, there's a problem with this question. They should have given you the speed of the ship. So the problem is with the question. But from what I've worked out, it looks like the speed of the ship is 9 knots. 9 or 10, doesn't really matter, but we're just getting the principle correct. So what do we do then in this question? You DR. Everyone familiar with DRing? It's an estimate. I estimate that I'm going to be somewhere here based on the speed of the ship. Now what do I do? At 0800 I was there. I do not know what time I'm going to be there, but I'm told the next fix that I do has to do with Whittle Rock. And Whittle Rock is somewhere there, isn't it? Huh? The fix at 0900. I fix using Whittle Rock. And Whittle Rock was 227. So Whittle Rock is to the west of me. 227. Whittle Rock is going to be somewhere there. 2.4 miles from Whittle Rock. If you fix, you are not on track, né? If you do that fix, you'll see that your ship is off track. Your ship is somewhere there. So you're coming down here. So you see that I am to the left of my track. So now you think this is the fix at 0900. So now you have to figure out what could have possibly happened. What made me to be off course? It could be the wind, but mainly the current. So I'm experiencing some tidal stream there or some current that is taking me off the course. So if I am there at 0900, where was I supposed to be at 0900, assuming that there is no current or wind? That you establish by means of EDR. So you've got the given speed there is 0, it's 9. So using your DSTV thing, remember you need to show all your working. So I want, how much distance am I going to cover? I want the distance. So D equals to speed times time. And then you populate your formula. The speed is given to you as 9 knots or 10 knots. Multiplied by the time. The time is 1 hour. It's a useless thing to do, but you still need to show it. Because at the end of the day, it works out to be capital M. So it's miles. Then what do? Take my compass, go measure 9 miles along the latitude scale. Remember, a mile is a minute of arc of latitude. So you measure along the latitude margin. Everyone's got that 9. So what do you do then? From the first position, you just make a small incision along your course vector. I estimated that I should have been there, but for some reason I found myself there. So something must have pushed me there. So how do I know? I connect where I should have been and where I am. So I connect that, and what are you getting? Take that line to the center. And which way am I going to read? Up or down? Down. Why down? I'm not there, I'm there. So this thing pushed me that way. So which means as I was traveling here, as my ship was moving here, slowly I was being pushed to the left, but I was not realizing it. I'm only going to realize it when I fix the next time. You see? So there was something pushing me every minute, slowly, without me realizing it. I'm only realizing it when I fix. That's why you need to fix frequently, especially when you are doing coastal passage, because you are running a risk of what? The greatest risk is the risk of grounding. So this thing pushed me up because I was supposed to be there, but it pushed me that way. I ended up there. So I'm going to read it up. So it's what? 350. So I see, I can extend this line so that I don't work inside there. I don't want to clutter my work. So, okay, I extend that line. I know this is my current. It gets 3 arrows, and it's pushing me in the direction of 350 degrees in a true direction. Now, all I need to do, the question says find what? The direction and the set and the drift. Remember, set is what? No, set is the direction. Drift is how much, drift is the speed. You must know the terminology. They can use any terminology, either set or drift or direction and speed, or what's another name for speed? It's drift, speed, and what? Rate. Those 3 are synonymous. So now I just need to find out what was the strength of this current that was pushing me. And the strength will be constituted by that vector which joins the dr and where I actually end up. So I go measure that, and it's how much? 1,9. Yeah, 1,9, 1,8, depending on your drawing. We're not all going to have the same one. So 1,9. So now I know the speed of this current. I write it there next to its course. It is 1,9? 1.9. That is the speed.
No, it was the distance, but then it's multiplied by 1 and you get the speed.
Yes, but we should not do that shortcut. In your answer sheet, you should work it out. The distance that I got is 1.9, and then using the DST relationship, you show that you end up with the same speed as 1.9 knots. Simply because you're multiplying 1, it stays the same thing, but you should still show your workings out. So now you've answered the question. What was the rate and the speed in the past hour? So I experienced a current of 350 in the direction of 350, pushing me in the direction of 350, and its strength was 1.9, so it's about 2 knots. You've solved the problem. So now what are you going to do now to get back to your course? This is the course that you want to make good. Now we have to counter. You know now that, oh, I'm experiencing a current. Now we have to counter it. Exactly. Okay. So you don't. So what we did wrong here, we discovered the current, but then that course there is the course to recover, né? But it's not the course to counter the current. We haven't countered the current. So we need to redraw it there, same magnitude, 2, in the same direction. And then from there, you join. Or since you discover your current, and now you've discovered, so you need to counter it, now that you know about it. So then that becomes the course, which is 1.4. We've tested it, it's 1.47.